what is DevOps? Well, the funny thing about when you say what is DevOps, you ask 10 people what DevOps is, you're probably going to get 20 different answers, right? But at Microsoft, DevOps means something very specific to us. DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. And now notice I said that really, really carefully, right? And the reason why is because, well, one of them, that definition was created by my manager, so if I get that wrong, right? The other thing is because every word of that was designed very specifically, right? The key is we want to continuously deliver value to our end users, and this is vital in today's world.
Hey, I'm sorry to start off on a somber note, but you're watching AzureFunBytes. My name's Jake Gordon. You know, this is a tough week. We've been gone for 2 weeks and coming back, and to come back with some sad news that we recently lost our friend, our colleague, our DevOps rock star, Abel Wang. I really appreciated Abel and all the things that he did for this community. He was on this show a bunch of times. He supported everything that I was doing with it, and he's just a great person. And so it's tough to say goodbye, but I just wanted to take a moment and recognize that that's what is going on, and that's how I feel. I loved Abel. He was a great guy, and I'm going to miss the hell out of him. So thanks for giving me a moment. You're watching AzureFunBytes. My name's Jake Gordon, and what do? Well, we get together and we talk about the people, products, services, and even the complementary products, which is a big deal today because we're going to be talking about something that works alongside with Azure, and just so you have a great Azure experience. So I've been gone a couple weeks. Sometimes you got to take some time off, and you know that's what I was doing. And to be able to kind of really understand a new technology, I wanted to bring in somebody that I've been talking with on Twitter for like the longest time. We have a bunch of mutual interests in metal and technology, and so I'm going to bring him in. This is Adron Hall. Hi, Adron. How are you today?
I'm doing pretty good.
Well,
all things considered.
Yeah. Sorry I had to walk into a bit of a memorial coming first, but you know, I felt it was necessary to kind of say something. You know, you lose somebody, and especially someone that was, you know, as important to this community as Abel was. It's hard to not want to go out there and just let people know how much you cared about them. But other than that, you know, we've got a really good show today. I know you're here to give us a ton of information on GraphQL and how GraphQL can help you build, query, and make API development easier.
Yes, that is what I'm going to talk about. Got a few things to show everybody today. It'll be based around the Hasura API product. Mm-hmm. I'll show you how I have a repo set up that does a deployment out to Azure and basically deploys an environment. It uses Postgres and SQL Server, just in my example that I have. And then also it sets up some tables, does an initial schema migration just to get you started. Of course, when you start with nothing, it's very easy to build out, and I can show a little bit of that and then answer questions as they come and discuss some of the architectural ideas and the flow behind it, that how people can like integrate this GraphQL option into their environment to kind of give a new option around setting up their data mesh or their data services, or however they want to provide access to their data in their underlying databases.
Very cool. And so I want to remind everybody of a few things as we get started. First of all, we always have a poll every week, and that makes and this week is no different the other. And this week we're asking, are you currently using GraphQL to build your APIs? Let us know. You can go over to aka.ms/learntv, where you can go ahead and give us your vote. And if you go down the side, you'll also see we've got some notes for today's show, including some code that Adron has provided and he'll explain a little bit more as we go through the show. Also, if you haven't yet, check out Microsoft Learn. It's free education on Azure, gives you a gamified experience. As you can see, I'm a level 10 wizard. And I'm doing my best. So, speaking of wizards and level 10 and all that stuff, Adron, we kind of started talking because of a mutual love for heavy metal and technology, obviously. What have you been listening to lately?
I think my go-to lately has been a band called Orbit Culture.
Okay.
I've been kind of enthralled by not just the music, but some of the videos they put together. They have a real sci-fi angle that they take, and
Sure.
it's been fascinating checking them out, and also watching them grow and come up with the stories they want to tell from their music and everything. So that's been something I've been listening to, and also a lot of instrumental stuff lately. It's always good to code to instrumental stuff. Then I don't have to think about what people are telling me.
Yeah, I hear you. Geez, what was I listening to this week? I was listening to Vader from Poland. They're a great death metal band I like a lot.
Oh, yeah.
So I want to kind of get started and talk to you a little bit about the technology. But before we do, I'd like to ask you, and this is a question I always ask everybody: how'd you get here? And so, how'd you get started, and how did you end up where we are today?
So first, I took a left down on the main street down there. No, but in all seriousness, I think it's interesting that we just talked about heavy metal for a bit, because the way I got into computer programming and working with computers to begin with was actually through music. I had started studying music years ago in college, and also had been playing music, just various venues and things like that around the New Orleans area. And by doing so, I had started helping people with computer problems and doing things like that. But then I also started to fall into the realm of building solutions for them. And I came upon this marvelous fact at the time that I had no idea was true. I found out that you could get paid to write the code parts and build applications. So I might have been a little naive at the time, but I found out quite quickly, and then got more and more into software development, and also building out systems, environments, everything from networking, the ground up, the whole stack, so to speak, to help build solutions for people that were trying to get things done, from nonprofits to for-profits, whatever. I was helping out everybody that I could find at the time. So
You were at DataStax for a little while, am I right?
yeah, previously I was just at DataStax, and that's when I actually got into GraphQL, which it was very simple the way that I got into GraphQL. Someone came to me and said, "Hey, will you build a GraphQL server?" And at that point in time, I knew what the word GraphQL meant, sort of, kind of, and that was it. So I had to dive in, and they basically just right into the deep end of the pool, so to speak, and start figuring out how GraphQL servers were built, how the intention to connect to the data and retrieve the data was structured, how you would pull those things in, and how you would ask for data from the GraphQL query side, how the clients needed to work. The whole kit and caboodle. I had to start from scratch. So I did that and built some prototypes, and eventually got the GraphQL element of the current DataStax database as a service solution built and deployed,
Like
which they have running right
Cassandra.
now.
Around Cassandra, right?
Yep. So which is also an interesting paradigm, because it's a distributed database, and it doesn't have relationships. There isn't a built-in element around that aspect. And with GraphQL, as you would assume, you have various entities and things that would be related and nested and things like that. Like the objects relate to each other. So you have to kind of make arbitrary decisions on how to connect those when using an underlying data store like Cassandra. So it was an interesting challenge. But I have since moved on to Hasura, and it works on relational databases like SQL Server and Postgres. And with that, you have a known way that the graph would be implied and to work, which is really great, because then not only does the GraphQL give you what you expect based on those relationships without you having to work on a lot of implied arbitrary pieces to structure a schema, you have basically what is in the database. So you have it mapped back and forth. So the database administrator would have relationships and manage the database from that schema perspective, and the person writing to the GraphQL could write and have those correlative graph elements of their queries come back the way they would expect, without a lot of, you're basically not having meetings about it. You know what you're going to get. You have more understanding just because of the implied nature of the database.
And from what I understand with GraphQL, you're not necessarily needing to do a number of requests. You can do a single request. And am I right that there's some kind of like discovery in that API where you can actually see the functions that are capable?
Yes. So and you'll see it in action without seeing it in action when I show you the console in a little bit for Hasura, because of the ability of GraphQL to provide kind of the introspection, as it's called. Whenever a client queries or asks for data, it can introspect against the API endpoint to know what is available to the client. So based on permissions or whatever the system would allow, it can ask and say, what can I get? You can get that information back, and then you can structure your query based on that. And because of that, just like right there in the screen on the GraphiQL image there that's animated, the little GIF animation or GIF animation, those elements, because they're introspected, will come up with an autocomplete, which is really great. I mean,
everybody likes tooling. Everyone
exactly.
Loves tooling.
I was going to say everybody loves to be able to type just a little bit and go, oh, there's the thing I want that I was trying to remember. Because having those little like kind of seeds to work through stuff give you that quick mental ability to put things back together without having like hard rote memorization about every little aspect of the API, which is really great. And it by proxy of that, it helps to really kind of boost the progress you can make during your development cycles without needing to go back and have the database open in one window and this thing open in another window, and always having to like check back and forth across all these things to make sure you have every little piece right, when the system can introspect for you and give you those pieces and make sure that you have casing right, spelling right, you have the right object type pieces and all that kind of stuff. So like whether you're using Visual Studio Code, or whatever, there's a lot of introspection capabilities to look back against the types, the mutations, the queries, all of that. And it just makes it massively simpler than trying to fight approaches.
Gotcha. And so I just really wanted to show that within VS Code, to show you that there is, the native tooling or the GraphiQL, and then there's also support within VS Code by the extensions library to be able to provide you with IntelliSense, linting, of course, provide you with some snippets so you can do some autocomplete of code, just like what we saw on the website in that GIF. So we've given people, I think, a good introduction so far, and if they want to go and check out some of this, they can go to the GraphQL website. It's graphql.org. And while you're clicking around, I want you to make sure that you take the poll and you let us know if you are currently using GraphQL to build your APIs. If you are, head over to aka.ms/learntv. Let us know. And then remember, if you have questions, you can put them in the chat. You can use the native chat within LearnTV, or you can use whichever service that you're using. I will get your questions. So, Adron, we've gone through some introductory stuff, and I'd love if you could kind of show us a little bit. We got a good 45 minutes of time to be able to start digging into how to build with this, how to automate it, throw the DevOps at it, if you will.
Mm-hmm.
So, if you want, I'll bring up your screen and we can kind of get started.
Let's do that.
And
yeah,
I'd love for you to kind of give me some information on Hasura as well. I think that would be really important.
Definitely. I will give lots of information on Hasura. Just like this repo that I'm about to show, for one, you're going to get two portmanteaus. Hasura is the combination of Haskell and Azure, which is Haskell, the programming language, and Hasura is a daemon that you can look up on the internet. There's a lot of great art. It is safe for work, 95%. Just preface that a little bit if you do search for it on Google. Just make sure have moderate on or something like that. You'll get all the good artwork. It's beautiful stuff. It'll give you a lot of research to check out there. It's quite fascinating, the whole thing. So that's one portmanteau. And then, of course, there's my repo, which is Azure, which is the combination of Terraform and Azure, because I'm using Terraform to get Hasura, the databases, and everything else deployed out to Azure. And I'm going to show you that repo right now.
Okay, let me bring up your screen, if you don't mind taking down that window, just so we remove the recursion from things.
Yeah, no infinity loop into emptiness. Cool.
There you go.
All right, so to start off, I'm just going to tell you what I've kind of done before Jay and I jumped on the stream here. I ran my Terraform script, which right here you can see in this bit. It's executed already, and it's deployed a bunch of stuff out to Azure for me. And I'm going to talk about what that is real quick now, and then we'll go take a look at actually what was deployed. So right here is my script. I have the Terraform that is executed. I pass in some pertinent information, which is basically I'm scraping some environment variables for the username and password so that I can keep them secret from all of you, my dear friends. However, if you go get this repo, you can just set those variables and you can deploy this yourself in your own Azure account. From there, I move into the migrations directory, and that's where I get into some of the powerful Hasura CLI capabilities, where the Hasura CLI gives you the ability to create migrations and things like that for your database. When all that's run, then the last step after all that, the migrations, the metadata, and seeds are put into place, it opens up the Hasura console. And I'm going to run that again, just myself, because I had stopped it a minute ago.
Okay.
Type Hasura console, and that'll bring up the console just like so. And over here to the left, you can see a whole bunch of Explorer objects. In the center is that GraphiQL interface. That's the standard one that's used in the industry for pretty much any GraphQL query writing. It's built into the Hasura console. Right here is the API endpoint, where you could literally right now go write queries against that if you wanted to. And any queries I put in the GraphiQL interface will be executed against that endpoint. The cool thing here is I can go over and let's say I want a list of railroads. So I'm going to ask for the name of railroads. Run the query. There it is. So this is what was deployed just about 20 minutes ago. I've put in some trains over there. For those of you that know me, you know I'm into trains. I'm always riding around on trains. So I figured I'd make a trains database, which I have here.
Sure.
That's the query for that. If I wanted to add another train, and I just go in and type mutation, that's basically your CRUD capabilities for those versed in SQL. Mutation in GraphQL lets you insert, update, delete, all that good stuff. If I hit the, let's see here, control space, it'll start to autocomplete. There we go. And you can see all the delete, insert, update, etc. options.
Gotcha.
All of these things might seem like I spent hours and hours and hours and hours creating. However, I'll show you right here one of the big powerful pieces of Hasura. So I ran these migrations and all that stuff. I created these in the database previously. So let's say you have a database already. When I add the database here in the database manager, a list of elements come up and are listed here, such as you can see too. One's the buffer cache and stat statement, which is just some Postgres view table functionality or something. It wasn't tables that I wanted. However, all these other tables that you saw in the API that I just showed you were once listed here. You can click track all, and it brings it all over here to make it active elements in the GraphQL. So the two core steps is you start Hasura, you point it at a database, then you just pick whatever tables in the database that you want, and it shows up as a GraphQL API endpoint entity with various relationships and things like that that you can connect to. If I go into railroad systems, which I just pulled the list of railroads from, here is the interface. And this is basically over here, you're just interacting with the data. You can edit things and do all the things that you would expect to do if you were working with a database interface, which is what this is. And you can also go in and you can modify the actual table entity, which would then change what the GraphQL API endpoint makes available. You can also set up permissions, connect the relationships like right here. For example, with GraphQL, you kind of expect those relationships to know about each other. And this is one of the things that I really love. And I'm going to show you this in GraphQL real quick, just so you can see the kind of beauty of it versus trying to write a join query. Like right here, a railroad is run by an operator. And there's a relationship that gives you an array in this particular context. So if I go back over to the GraphiQL interface, I bring up a query, go over here, you'll notice that the object that this is related to, here's the railroads. Then we go down to operators, and I'll go, all right, I want to figure out what train belongs to the operator per the railroad. So if I run that now, I get Amtrak runs things like the Coast Starlight 11 train and Coast Starlight 14 train. Sound Transit runs all these trains in their territory, etc. And you'll notice that there's some nested elements here in the JSON now. And that's what correlates, because the GraphQL knows that these entities are related to each other. It knows that the railroad has X operator, which then connects to X train. Now in SQL, for those familiar with that, that would be like inner join, outer join on these three tables. It would be a multi-join across those things. But in GraphQL, you just have this nice structured element here. You would write this query and get the data back very cleanly. There's not a lot of other peripheral joining elements. The relationship is already inferred from the structure of the GraphQL schema. So that's one of the beautiful things that I like a lot about GraphQL. I always felt like those should be more inferred in SQL, but SQL is a little bit more verbose about that.
So how modular are the data sources that you can pull from? Like if I wanted to use something like a Cosmos DB database with so let's say I want to work with documents and the MongoDB API.
Yeah, for sure.
Could I use that?
So here's the thing. Some of the databases we don't support yet in the Hasura product itself. However, here's the really awesome thing. Let's say you have a Cassandra API that does GraphQL, or the Mongo Atlas solution that does the GraphQL, and you want to connect to some of those GraphQL API endpoints, right? And you want those things to come in and have cross correlations and relationships and stuff for your GraphQL API. You can go to remote schemas and you can connect to a remote schema out there. So if you have one of those, like if you got some GraphQL running on Cosmos DB, which I think I've just seen like some libraries or something that I was looking at, because I was actually curious about that too. I've been running some of the free tier Cosmos stuff, playing with it. And you just point this at it. You'll bring back those introspected GraphQL entities and such. And then you can even draw relationships between the different entities with the ones that are in your underlying existing entities over here from the data sources that you have connected directly to a database. So one of the great things about this tool is that ability for it to act kind of as an API gateway and bring together all of your GraphQL schemas and organize them and relate them to each other in this singular tool, so you can provide that mechanism for your web developers, your app dev team, et cetera, whoever's using your GraphQL and your data, and you want to provide it via a nice, clean, singular API interface. This is a great tool to be able to do that with.
Wonderful, wonderful. So how am I building, say, APIs to do cloud deployments? Because I'd love to kind of see how, say, Azure fits into the whole kind of bundle here.
Yeah, so I'm glad you asked that, because that's exactly what I want to talk about now. The way that I have deployed this, and I'm going to minimize this. I do have a little bit of a local dev environment in this repo too, which is identical to this what I'm calling my production environment. Important to note, though, there's more security elements that you'd want to set if it's really production. This is an example repo. But in the Terraform here, I start off basically with, here's my provider for Azure. Okay, that's initialized. I set it up in West US2. And I know the resource group doesn't always hard map all of the resources in the resource group to the particular location, but I always try to keep everything physically close to me as far as where I'm in geographically. So West US2 usually works really well for me. So I set that up in this Terraform file along with all my variables and then these output variables. And I'll tell you one quick thing here about this. The reason I have the Hasura URI path and the SQL Server DSN is because then I can run the entire Terraform apply, and then at the end it gives me the 2 connection strings I need to do things if I want to, say, connect the enterprise tooling to SQL Server to go look at the database or build the database or something. And also it gives me the direct path that I can just grab real quick and put into code to execute against the GraphQL API. So that's just a little trick that I always do. There's always the option, of course, to open up the Hasura console, but I like to just have those available right away. So the next thing, besides making the obvious connection to Azure that I need, is actually setting up the databases. Now, there's 2 servers because I use SQL Server and Postgres in this example. Here is my SQL server, very basic setup, no extra peripheral settings set or anything. I just set it up to execute and build out in that resource group to the same location at US West 2, give it a 12 version, and then set up the administrator login and password. And of course, everybody can have my super not secret ones right here, because that would just be their super secret ones whenever they run this. Here is the Postgres server. It has a little bit more settings just because of Postgres. I set up like the basic storage, retention, and some of these things, they're required elements. I make sure to turn off the geo redundant part just because this isn't real production. So I don't need that.
We don't need a whole bunch of replication and
exactly
geo distribution just for a demo.
It's great to know that it's there though. So it's a nice setting to have to set to remember to when you do go to production that, oh, you probably want to flip this bit or something to turn that on. But anyway, I got all that set up, make sure SSL is enforced. I'm using version 11 right now for this. 12 is out, which has quite a bit new additional column features that people probably want. So maybe they want to switch if they're using this. But same thing goes in the same resource group. And both of these are using the Azure, basically the relational database service for each of those respective databases. So it's the actual SQL Server instance that is running and the actual Postgres server instance that is running that these are spinning up. Once those 2 things spin up, of course, I have databases. I like to set up a named database in each of the database servers to use instead of using the default or the DBO or whichever database, the default databases that are in those. I don't like to tamper with those. I like to leave those for the database servers. So I always make my own database. And in this situation here, same thing, setting it up in the resource group. It designates the server specifically that it's going to, and then just adds a named database on that particular server instance. Then finally, and this is one thing that I've answered this question for a few people that have actually done this exact deployment. you got to set up your firewall rule for Postgres and for SQL Server. And basically all this is doing is the database service in Azure needs to know that there's going to be a container that's going to connect to it via the Azure network, right? So I just open up the IP endpoints between each of those things so that when I spin up the Hasura container, it can then connect directly to the database instead of attempting to do something crazy like go out of the internet and then back into the internet or something like that. So it just keeps everything kind of in a, basically in a DMZ, right? In Azure. And then I can just do something like only expose the Hasura GraphQL API endpoint if I need to do that. That way I can keep the databases just in Azure and kind of lock down a little bit.
Gotcha.
So that's done. And then the last step here is the actual Hasura server that is spun up. And basically I'm using the, I think I get this acronym right, ACS, Azure Container Services.
ACI, like a container instance?
Yes, that's it.
ACI.
I get the acronym messed up all the time. But yeah, so I get a container and I'm just using the image that's actually available out on Docker Hub. So it's Hasura / GraphQL engine. In this case, right now I'm on v2.0.1. And I think we're actually at 2.4 now. But anyway, the image is designated right here. It's an extremely efficient instance. So I only have like half a CPU and 1.5 of memory. Doesn't need a whole lot, especially for just development purposes. Again, it's written in Haskell, so it's super efficient. One of the rare applications that's written in Haskell. The location set up in the same place, etc. It's running on a Linux instance. I make the IP address public, right? And then I set a few of the environment variables specific to the server, such as the database environment variables here. As you can see, this is the DSN for SQL Server. And then right above that is the Postgres URL connection string. And in that, it pops the username and password in it as it needs. And I tag it as part of the data layer. And then that's that. Boom. That's what it deploys. I feel like I should mention, just in case, the Postgres URL needs to stay secure. So if you're pushing this via Terraform, make sure you use a good secure location for the metadata of Terraform, whether local or whether you're pushing it out to Azure Blob Storage, or better yet, if you use this and you kind of modify it to run in the built-in cloud CLI, that's a great place because then you won't have any of these accidental secrets sitting out in the open anywhere because they will get put into the state files. It's important to note because we don't want secrets leaking. But yeah, so that's basically the Terraform deployed Azure side of things. And matter of fact, let's hear. Well, we can continue on whatever topic, but I was just going to see if I can pull up my Azure portal real quick.
Sure. Love to take a look and see what you built.
There we go. It should just have, theoretically, cross my fingers. Ah, there we go. Yeah, so we can see the SQL database, the Terraform Postgres server with the little bitty elephant icon. Let's see if I can click it and get a bigger icon. It's a little bit bigger. Anyway, there's the Postgres server, various metrics displayed. And then the Terraform SQL server. It's interesting that there is a database that's specific to each one of these servers, but in Azure, as one might suspect, SQL Server is listed, and then the database is listed individually too, versus Postgres, which the database, it's assumed that you have to assume that the database is on the server, and it is. I know it is, but I just find it interesting how the resources are listed. And then, of course, there's the container instance right here, which is nice. So always good to be able to bounce in there and check out all your information. And if you ever miss, I showed you the two output variables that I have in Terraform. If you ever miss that, though, you can always get the fully qualified domain name right there, which is something nice to have. You can get it there, and you can also get it via the Hasura interface, via the API endpoint right here. It's just that basic bit right there. The v1/GraphQL is where the API endpoint always ends up. So a lot of options to put all of that good stuff together.
Awesome. So I just want to take a moment and remind everybody, just give you a second to kind of reset, if you will. That if you'd like to take today's poll, we'd really appreciate your vote. Head over to the Learn TV website. That's aka.ms/LearnTV, where we're asking if you're currently using GraphQL to build your APIs. So we'd love to hear what you have to say about that. And of course, if you have questions, please put them in the chat. We're using the native chat for your video service. If you're using Twitch, Twitter, YouTube, and of course in the right rail on Learn TV, you'll see here there's this Ask Questions section. You could pop your questions in there. And then of course we've got a bunch of docs for today. It's in this as well. You could take a look, and it'll also be in the show notes. So we've got all that, and like I said, make sure you sent in your questions if you have them. So Adron, I'm curious, is there any way you can show me just like the structure of an API and how we can do some data fetching?
Sure. So if I bounce over here, I mean, the basic structure of the API is you make a post. So that part of it is straightforward with GraphQL. You're always making a post. It's not like REST where you have to use the different verb and then add various elements that way. Some of the things you can do here too is you can set up and pass different headers. So like your super secret header and then give it some value, things like that, just here from the console. Of course, if you set up permissions on any of these various elements to limit what certain users can access or something like that, there's ways to pass headers and then set the permissions per table, per column, etc. Like let's actually look at that, because that's quite fascinating. Let's say I don't know what table this is. It says schema. It's got a few values here, but if I go into permissions, and right now it's got admin has access to everything, right? But let's say we have a new user called HR for human resources. So we add HR here. Let's see here. Did I break my interface somehow? Oh, there we go. And then you just click on what you want to set. For example, insert. I want to set insert permissions. HR is cool. They can add stuff to the schema, so I'll write in without any checks. And then they can insert the schema map and the connection ID, because I guess it's related to connection ID, I assume. And in this case, you know, it'd be something like this where I wouldn't want them to set the ID, for example, because I probably have it set in the database. So I'm just going to not mess with that one. And then I'm going to click Save Permissions. So then you'll see a little filter symbol come up that shows that insert now is filtered based on the role of HR. And you just set that role in the header information. You pass that as a value. You'd add that in your system, and then that would filter the permissions and basically give you authorization access across the board on inserts, selects, updates, deletes for, you know, rows, individual pieces of data, etc. This interface is pretty cool too, because like you can do custom check, and you can really dig in. Like let's say the created at date is I don't know, equal or not equal to a certain date, and you can check for additional values from the header, like the Hasura user ID, things like that. So you can really get in depth. And what's great about this interface too is as you get in depth and you go however many layers, it builds out the JSON for you right there. That is actually the check that is being built, which is cool. So as you're sending things and as you need more of the information here, this is a great way to dig into that. So that's some of the ways you can like manage the access and control to your data in the database from the API point of view. And that's authorization. It's important to note from the Hasura perspective. So if the database administrator does other peripheral checks in the databases or sets permissions that way, and gives you different connection strings for different APIs, all of that can be managed because you can just set additional data connections to the databases, basically by going in here add another connection to say even the same database, but using a different connection string for a different specific API, things like that. But otherwise, everything is done through the singular post API endpoint right here. And then basically whatever is added in the data element of that post request is where you have all of your GraphQL, basically all of this, where you're sending it against your API endpoint.
Gotcha. So, we got, I think, about a good 20 minutes or so left. And I was curious, we've seen a lot so far. But what else would you have to show off today around, say, data layers and how we can, say, manipulate those data layers that we have as part of our like how can we do posts that'll actually make modifications to the database via using this?
Yeah. So one of the examples, let's do an insert and take a look at that. And I'll also show you how to debug some of this stuff too, because as one might expect, even though you have this beautiful GraphQL API endpoint to work with, in the background, there's still SQL being executed. And sometimes you need to know what that SQL is, and you need to know why it's performing a particular way. So let's take a look at an insert, and we'll just start off with mutation. Insert, and then let's do.
And can you explain the mutation there?
Yeah, so this particular thing is the mutation is going to be, from the post perspective, you're issuing a post and you're asking data to be mutated. The reason it's just stated as mutation is because you're not defining whether it's like an insert, update, delete, or whatever. You're just stating that the data is going to change, and the thing that you're calling is kind of a function that is going to change or mutate the data. Of course, as you can see here, based on the names of the functions I'm calling, it's going to do a specific thing that we can clearly see. In this case, we're going to, where is it there? We're going to add a railroad. So insert railroads. And here's another place where you don't have to make redundant calls to the GraphQL system. And this is one of those things I love. In SQL, this would actually end up being 2 calls. So let's add a railroad. Well, I should actually add railroad. Gonna make sure I'm using the right one. Insert. Railroad. There we go. One. I just want to add one. There we go. Add one railroad.
Mm-hmm.
And then I'm going to go over here. This is one of the things I love about the Explorer, because if I try to hand type this, I so often just get the pieces wrong.
Sure.
So over here, I'm going to say this is going to be our new fancy railroad. And then I don't have history, but I do just want to at least add the name. And then when that's added, I want the ID to come back. And in a lot of cases, when you add a core primary piece of data to a database, you would routinely have peripheral data that you may want to add that's related to this primary piece of data, often by something like a foreign key or whatnot. In this case, you'd want the ID to come back so that you can use that ID in code or whatnot to add something to that other entity, whatever it might be. So in this case, with a mutation, you always have that returned element that you need to enter into your query as you execute this. And in this case, I'm going to ask for the ID. So this is going to be called, and then it's going to return the ID, just like this. So my ID is this little short ID that I have. So I added that. I now have the new fancy railroad, and the ID of the new fancy railroad is this. But let's say, it's later on. We've been doing some stuff. I'm going to query my railroads now. There we go. And let's get the ID. And then I want the name. And then let's say description. We won't have a description, obviously. But I'm going to just get it in the query, and then I'll ask for the created at, and we'll do the, there it is, updated at. So I'm going to run this query, and this gives us all of the railroads. I'm going to scroll down, and there is our new fancy railroad, right? Now, let's say this is a query that has a lot of other peripheral elements to it. Like, let's do where, let's do name equals, oops, new fancy railroad. So now we just get our one element back, right? Now this is clean, not a lot here. It's pretty obvious what we're asking for in this particular query. One of the things that I can do, let's say this was responding slowly. I needed to check into what was up. If you click on Analyze, you get the actual query that is being executed against the database, where you can check out how the where is being structured. You can see the actual select itself and how it's structured there. And then below that, you can see the aggregate and the execution plan. And thus, for more complex queries that go across tables and such, you can really dig into where your performance hits may be occurring. And that really becomes evident, like if I ask for this, but then I go down and I want to know, let's say the trains ID, which of course there won't be any just yet, but like this would return a list of the trains that I'm operating as this new fancy railroad, right? And if I go back to Analyze, you can see that the query has changed. There's now a left outer join lateral that's getting coalesced, etc., and then another left outer join lateral that pulls against that. So this is what the SQL query looks like. Here's the execution plan and the subplans within that, all for this nice, beautiful, simple query right here. So that's one way that you can create nice queries with GraphQL, get back what you need, and then also dig into the SQL in case you bump into any of the famous proverbial performance impacts that databases have. Even though these days, I mean, databases are so fast, everything happens instantly. So I'm sure nobody will run into any problems whatsoever.
So I'm going to walk through doing a query if you want to kind of sit through it and talk me through any of the parts that I may get right or wrong, if that's cool.
Yeah.
Great. So I'm going to go ahead and change my screen. Let's go ahead and go to share. Ooh, recursion. Let me go ahead and share my screen. Let's do entire screen two. So what I've got here is a few things. So first of all, I've got this VS Code. I have, of course, the GraphQL extension installed. And I wanted to just do a quick review. There's this deploy a GraphQL API as an Azure function that you can use right here. There's docs on it. I shared it in the chat. You could take a look at it here. But what we're going to do is just work through this clone and run the sample function code that we have here. So let's just go ahead and we'll do a simple git clone. And what we could do is just go here, clone from GitHub. All right. So I'll just put it on my desktop, save right there. And then this is a JavaScript application. So all we're going to have to do is go here and let's step through this and maybe you can explain a little bit to me here.
For sure.
So here's this function.json that's within here. Do you want to like step through the bindings and tell me a little bit about what we see here?
Well, this is for the function itself, right? The Azure function.
Sure. Oh, excuse me. Let me bring up the index.ts.
Yeah, there we go. So, okay, yeah, this is the beautiful part. So right here, I think in the example docs, it said that this was a hello world type function. So what you got here is you got your type defs, which is your type definition of your query, your entities, your things like that you would be asking for, or that you would be sending to the API endpoint via your query that you're asking for. Then right below that you have, because the resolver, which is the thing that makes the calls from the server side to the database or to the data store or to whatever is in the back end that's going to provide your response with the data, with your response of something, some type of answer, that's done with a resolver. And when you have something like mutations, that's another reason for that type of verbiage, right? So mutation just means some type of thing is going to change with the data. You're not particularly stating from the GraphQL perspective that it's going to specifically be an insert, an update, or whatever. You're just saying this is going to change data somehow, and I'm going to ask for this change to occur. That is then sent to a resolver on the back end. Now, even with just things called queries, as you can see right there in the resolver, this one's a query specifically, the resolvers handle those too. So basically everything on the server side of GraphQL is some type of resolver doing some type of action against your data source. When you write a server, you can also have it be connected to any plethora of underlying systems, right? You could connect to databases, you could connect to text files. I mean, you know, it doesn't matter. It's completely wide open. There's no specific requirement for it to connect to any particular type of thing. It's up to you and what you want to expose via a GraphQL API endpoint. So, and you just expose those things with resolvers.
So I've gone ahead and I've installed this application.
Right.
And now we're starting it up. And so if I'm right, it's just starting up the GraphQL backend. Am I right?
Yep. Yeah.
Okay. So let's give this a second, and we'll take a look at the next part and start to query it.
I feel like I should mention too, just because in our serverless world these days, it gets very fuzzy what is or isn't backend sometimes, especially with talking about APIs. Like we just call this the backend, but it could very well be something that a web developer may be developing. And further back even is the backend, right? The database is back there somewhere. The data store is back there somewhere. So this is being executed in this case by Azure function, which is basically a systems element between whatever the thing you are connecting to and the thing asking for whatever information that you want to provide from the thing you're connecting to. So it's kind of interesting to wrap one's head around where this piece sits between the different pieces of the architecture as one builds out their application. But it is pivotal to understand over time where these things sit, just so that you know where you are or aren't making requests and why you're making them to various points.
Okay, so let's try bringing up the back end. Now that we've gone ahead, we started it. So give me one sec.
I don't know this repo very good. Does this repo have, does it just start the server and then you need to make a function available? Like you have to add the function, I think? Okay.
Yeah, for some reason it's not starting, and it's something with the version of Node. Let me do something.
Oh, nodes.
Yeah. Well, you know, when you do it and you do it live, this kind of stuff always happens, right?
Especially when you have, what is it, 16 versions of at minimum 16 something versions of a thing.
So here, I'm bringing this up here. Let's take a look again. Okay. So it looks like we're doing a little bit better here.
Yeah. It says that access to the path is denied. Is that just because the function isn't there yet?
There we are. So
Cool.
I've got my back end up, and now
Nice.
I want to just do a query, and I believe that all I really need to do is just hello, which is the function that I'm doing. And if I just go here,
Yep.
there
That
it
should be
is.
Yeah.
And that we can go back to our code here and see here. There's that. And so the next step here, obviously, is working to create an Azure function. You can then deploy your GraphQL API via VS Code over into your Azure account. So we're getting really, really close to the end, Adron, and I wanted to just kind of wrap things up. And so I want to just share with people some places where they can get some information if they like to. Obviously, the big easy one that I want to make sure I lay out for you is the Hasura website. Make sure that you go, you check that out. It says you can get started in 30 seconds and start building. And you can go over to hasura.io and get all the information that you need. If you'd like to find out more about GraphQL, there's a great website, and if I'm right, GraphQL is all open source. You can take a look at the GitHub repository and see everything that's going on there. So let's go and check out our poll. Most people said no, and that's unfortunate. But now that they've got a little bit more information on everything, they'll be able to start building using GraphQL.
All 6 of those people need to come talk to me. Let's get some GraphQL stuff set up, and we'll see how you like it or not. You don't have to like it, but it's possible to love it.
So let me ask you, if people want to get in touch with you on the internet, where's the best place to find you?
Probably the best place is via Twitter, which is just @Adron. I'm also
right there below. You can kind of check it out.
But that's the easiest place, just because I kind of loiter on Twitter a lot.
As one does.
Yeah, as one does, exactly. Maybe too much. But also I am on Twitch and YouTube, but that is Thrashing Code versus Adron. But if you Google me, it's pretty easy to tell me apart from all of the other Adrons. For one, I'm shiny right here. However, if you do run into the other Adron, she does play some great folksy music. Check her stuff out. It's great. There's no correlation, but she does show up in my Google results, and I guess I show up in hers. But yeah, you can get to all my Twitch and YouTubes, and I write at compositecode.blog. I also blog pretty regularly on pretty regular. That's a relative statement when it comes to blogging. I blog pretty regularly. I try to on the Hasura blog too. We got a lot of good stuff that we try to keep updated on a regular basis there. I think that's the main places, those.
Gotcha.
Twitter.
Well, all that stuff is going to be on the show notes. There'll be blog posts that'll come out very soon, so you can take a look at everything. So that being said, Adron, it's time to say goodbye. Thank you so much for being part of this today. I had a really great time spending this hour with you. I learned a bunch. I went ahead and I started that back end. I got an API running, made a query. We learned about Terraform and all the things that you can do. And just thanks a lot, Adron. I really appreciate it.
Yeah, sure thing. Thanks for having me on the show.
You're welcome.
I'm glad that we got to do this. I love watching it too. I have watched, I think, 90% of the episodes. And I just noticed it said week 52. That means there's been at least a literal year worth of episodes, right?
Yeah, it's been great.
Yeah.
Anyway, let's say goodbye to everybody. We'll give them the big wave goodbye. Thanks a lot, everybody. We'll see you next week. We're going to be doing, I think, another session with Pulumi, and we'll check it out. Until then, we'll see you next time on AzureFunBytes. Take care.
Cheerio all.